Today's video will demonstrate how to take an English problem definition and turn it into pseudocode. Hello, I'm James Helfrich. Pseudocode is a tool that allows us to translate English design ideas into a specific programming language, which can then be compiled. This video will demonstrate that process. Pseudocode is a vehicle transporting the designer's high-level ideas into a programming constructs that can be readily converted to code. I really want to focus on the word vehicle here, because a vehicle moves something from point A to point B. In this case, we're going to move ideas from point A when they're really poorly defined and abstract to point B when they're ready to write code. And so we're going to take these design ideas and we're going to transform them using multiple iterations to become more and more specific. So think of this. We're going to start with the problem definition in English, and we're going to try to get to machine language, which is what the CPU requires. Now, of course, we have a programming language which will generate machine language, and that's a good thing, but that's still a really big gap to go from English to the programming language. So pseudocode will start looking very much like English, and then through multiple iterations, we're going to transport those ideas until they become closer and closer and closer to the programming language. This is perhaps best explained by example. Consider the bubble sort. So the bubble sort is a comparison sort algorithm that repeatedly swaps the adjacent elements if they are in the wrong order, finding the largest item, then the second largest, and so on, so the array is sorted. This is a very typical English definition. So let's take a look at pseudocode will help us solve this problem. So first of all, I'm going to take that English definition and I'm going to have it completely unchanged. And then I'm going to add a little bit of clarity, a little bit of specifics according to the algorithm. First, find the largest item in the array and put it at the end. Then find the next largest item, put the next spot, continue until the list is sorted. Do this by starting at one side of the array, moving to the other with each spot, swap adjacent elements if they are in the wrong order. Now notice this is both English, but I'm way more specific about the algorithm in the second iteration. In the third iteration, I'm going to add a little bit more pseudocode and a little bit less English. For each spot, left to right, find the largest item, and then if it is bigger, then the target item is swapped. Okay, so a little bit of pseudocode in there, but still mostly English. Another iteration, and I'm going to have mostly pseudocode and a little bit of English. For I spots, and I'm actually naming the variable, it goes from the end to the beginning, and that's English. For I check, beginning to end, so once again, a little English. And then if they're out of order, if array of I check is less than array of I check plus 1, then swap them. Okay, so now I have mostly pseudocode here. For I spot equals num items minus 1 to 1, and that corresponds to the above line where I said from the end to the beginning. For I check equals 0 to I spot minus 1, and that corresponds to the English above beginning to I spot. And then if array of I check is less than array of I check plus 1, that was unchanged, but now I'm going to be specific about how to swap them by calling the swap function. And from there, then I can actually turn that code into Python. Here's another example. Write the pseudocode to compute an individual's tax burden. So first of all, I'm going to start with an English definition. If the income is between 15,000 and 61,000, then tax is 1,500 plus 15% of the amount over 15,000. It doesn't really make a lot of sense, but hey, it's not my fault. It's copy pasted directly from the IRS's website. Okay, so now I'm going to try to add a little bit more pseudocode. If 15,000 is less than or equal to income is less than or equal to 61,000, and that corresponds to the English. If income is between 15,000 to 61,000, then tax equals 1,500 plus 15% of the amount over 15,000, and that corresponds to the English above. So I'm just massaging this to have a little bit more specificity, but it's still a lot of English in there. Another iteration. If, and once again, 15,000 is less than or equal to income, less than or equal to 61,000, that's straight from above, that was good to go. But now I'm going to be more specific about how to compute the tax. Tax is 1,500 plus 15% times income minus 15,000. So now that I have the actual equation, I'm a full-on pseudocode. And so the next step is to fill out the rest of the pseudocode for the other tax brackets using the model I had before. And from there, of course, I can actually have the Python. And we'll notice that the structure of the pseudocode is reflected in the Python exactly. However, in the Python, I have specifics like comments, I have the colons for the if statements, I have the definition of the function, all that stuff that's specific to the language, but the structure of the algorithm was already solved in the pseudocode. This is example 2.1 and 2.2 in the pseudocode chapter of the software design textbook.